Hello and welcome to this video where I will be giving feedback for June 2019 Pearson Edexcel GCSE Statistics Exams 9 to 1. My name is Leanne Devlin and I am an Assistant Principal Examiner for GCSE 9 to 1 Statistics, and I am also a Head of Maths in a school in North East England. During my time as an examiner, I have had experience of marking foundation and higher GCSE statistics for the old specification and this summer for the new specification. I have also been involved in the Getting Ready to Teach events for the new specification. I will be taking you through some of the key points from the exam series and also looking at some of the questions that were on the papers, including student responses. In particular, we will be looking at some of the new topics on the specification, questions that involve students interpreting their results, the new extended response style questions, and how the statistical inquiry cycle was examined now that controlled assessment has been removed. June 2019 was the first sitting of the new 9 to 1 specification. All students sat two equally weighted papers that were worth 80 marks each, giving a total out of 160. Here we see in the top table the grade boundaries for each paper at both tiers. The bottom table shows the final grade boundaries for both papers combined. Approximately 60% of candidates sat the higher tier papers and 40% were entered for the foundation tier papers. On the old specification, it was approximately 75% for higher and 25% for foundation. So there has been a move towards more students sitting the foundation tier on this new specification. Here we can see the cumulative percentages for the grades that were awarded. Overall, just over 73% of students achieved a grade 4+ and 20% achieved a grade 7+. There are three assessment objectives that must be assessed on every exam: AO1, AO2 and AO3. The strengths of this cohort were seen on AO1 questions. They were really good at basic calculations and representing data, which were mainly the topics that they have seen before as they appeared on the old specification. Students struggled with some of the new content, particularly the AO3 and statistical inquiry style questions. This was seen across all papers and on both tiers, although foundation students struggled more with the extended response questions, often given brief responses that did not reflect the number of marks available. Also, students are losing marks for not using the correct statistical language, for example, using the word average when comparing box plots instead of the word median. I now have a selection of some of the questions from these papers and student responses for us to look at, along with the marks that were given. We will begin by taking a look at some of the new content questions. Overall, students made good attempts at the new calculations, particularly when they were given the formulae. However, overall the standard of responses on the new content questions varied. Foundation tier candidates often left these questions blank. The first question was question 16 on paper 1 foundation and looked at crude birth rates. This question had two parts, A and B, and was worth 3 marks in total. In part A, students were asked to work out the crude birth rate for New Zealand using the given formula, and over 3/4 of students were able to do this correctly. In part B, students needed to understand what crude birth rate calculations show. Interpreting what this means in context was a particular weakness of this cohort, with less than 1/4 of students accessing the mark in part B. Looking at the mark scheme, the first mark in part A was for a correct method and the second mark was for the correct answer of 12.8. Part B was 1 mark and was given for any answer that implied the populations must be the same. Here we have 3 different responses for part A of this question. In the first response, we can see that the student has the correct method and the correct answer of 12.8, so was awarded 2 marks. In the second response, they have shown a fully correct method, but then have an incorrect answer of 127.5. This was awarded only 1 mark and highlights the importance of students writing down all they're working out, as if they had just put the answer, this would have been given no marks. In the third response, we can see that they have the wrong denominator and this has resulted in the incorrect answer, so this response was awarded no marks. Now we will look at 3 responses for part B of this question. The first response was awarded 1 mark for a correct response that the population would need to be the same in both. The next 2 responses were awarded no marks as they have implied that the population sizes were different. The third response highlights a common incorrect answer which references one population being twice the other. Another commonly seen mistake was to show that one of the birth rates was twice the other by giving the calculation 12 times 2 equals 24. Now we will look at a new content question that was question 11C on paper 2 higher. This was a question where they had to understand the difference between Spearman's rank correlation coefficient and Pearson's product moment correlation coefficient on a scatter diagram. This part of the question proved to be the most challenging item on the entire paper. For 2 marks, students needed to be able to say which diagram most likely represented the data and give an appropriate supporting reason. We can see from the mark scheme that the first mark is awarded for stating figure 1 and the second mark is given for either stating Pearson's is smaller than Spearman's or for understanding that the Spearman's shows rank correlation whereas Pearson's shows linear correlation. The first response was awarded both marks as they have stated figure 1 and said that Spearman's is greater than Pearson's. The second response was awarded 1 mark for stating figure 1, but they have incorrect reason. 92% of students give an answer of figure 2 for this question, which scored no marks, and only 2% of students gained full marks, showing that there is work to be done for students to fully understand this new topic. We are now going to look at 2 questions, one from each tier, where the students have to interpret a calculation that they have been asked to carry out, as this is an important part of AO2. Interpretation questions are not new to the specification, so there's plenty of practice that can be gained by going through old specification past papers. This continues to be an area where students at both tiers struggle. Students need to be reminded that their interpretations should be given in the context of the question. The first question is question 9 from paper 2 foundation, where we will look at parts B and C. This is also a new topic question on absolute and relative risk. In part B, the students had to show that the value in the table was 18 for 1 mark, and then in part C, they needed to calculate the relative risk for 2 marks and then interpret their answer in part 2 for 1 mark. This question again highlights the fact that students perform well at carrying out statistical calculations AO1, but often struggle to interpret them AO2. From the mark scheme, we can see that in part B, students needed to show their working out as the answer of 18 was given in the question. About half of the students were able to answer this part of the question. In part C, they had to show a probability divided by 0.6 for the first mark and then a fully correct calculation for the second mark. In parts B and C, as the answer is given, the student can achieve full marks for their calculations and the answer need not be stated. In part 2, they needed to give a correct interpretation of relative risk, and 2 examples are shown here. Various calculations leading to the stated answer of 0.5 in part C1 were sometimes seen but not relevant and did not score. For the interpretation in part 2, some students came close by recognising which mode of transport had the greatest chance of lateness, but rarely with reference to the specific relative risk of 0.5. This first response was given 1 mark in part B for the correct calculation shown to get an answer of 18. C part 1 was given 2 marks as they have the correct calculation. In part 2, they have a fully correct interpretation of risk, stating that it is half as risky to travel by car than by bus, and this was awarded 1 mark. This next response was awarded 1 mark in part B for a correct method. Part C was awarded no marks, as in Part 1 they have an incorrect calculation, as we needed to see a probability divided by 0.6 for the first mark, and just seeing 0.3 was not enough. In Part 2, they have the incorrect answer that the car had the greatest chance of coming late, but they also haven't made reference to the relative risk of 0.5, so this was awarded no marks. We will now look at an interpretation question, question 10, B and C on paper 1 higher. This question also involved a new topic where students had to calculate a value for skew, whereas on the old specification, students only needed to be able to interpret skew from diagrams. In Part B, they needed to be able to calculate skew by using the values in the table and the formula that is given in the exam. From the mark scheme, the first mark was awarded for the correct calculation and the second mark for the correct answer of minus 0.6. The majority gained full marks on this question. It was rare to see an incorrect value given. In Part C, we can see that they needed to be able to interpret the answer that they have got in Part B. The first mark was given for stating that it was negative skew, and then the second mark was for a correct interpretation of the skew. The two acceptable answers are seen on the mark scheme. A follow-through mark was given here. So if they had an incorrect answer in Part B, they could still be awarded a mark for a correct interpretation in Part C. The majority of students could state that it was negative skew, but very few were able to interpret the skew in context of the question, and is another topic that needs to be worked on. In this first response, we can see that they have the correct answer of minus 0.6 in Part B and were awarded 2 marks. Part C was also awarded 2 marks, as they have stated negative skew and they have a correct interpretation of skew equivalent to the first one given on the mark scheme. In this next response, they also have the correct answer in Part B and were awarded 2 marks. But in Part C, they have only been awarded 1 mark for stating negative skew, as they have an incorrect interpretation. This was a common error seen on this question, where students give an interpretation of negative correlation and not skew. In the last response for this question, we have a rare example in Part B where a student has not got full marks. They were awarded 1 mark for the correct method, but have an incorrect answer of 0.6. Part C was awarded no marks, although had they said positive skew, it would have gained the follow-through mark. As mentioned earlier in the video, there is no longer a controlled assessment for GCSE statistics, so the statistical inquiry cycle is examined in the exam. Students are expected to make connections between different parts of the cycle. For example, they may need to assess how a specific method of data collection could impact on the reliability of the results obtained. Though many students made a start at answering these questions this summer, very few sufficiently developed their responses. Here is an example of a question that was question 10 on paper 2 higher and looks at cleaning data, identifying outliers and justifying their decisions. This question was worth 6 marks. For the first mark, they needed to give a correct reason why the data needs to be cleaned. Many students were able to earn this first mark and had a concept of what cleaning data was and stated that you needed to remove outliers, put data in the same units, etc., but then did not go any further with the question. For the second mark, they had to give a reason why it is appropriate to remove the outlier. For example, affects reliability. This mark was achieved much less often. For the next 3 marks, they needed to carry out the calculations using the mean, plus and minus 3 standard deviations, and then finally identifying the 2 outliers. For those who realise that they had to state the rule for removing outliers and work out if there were any, they generally achieved 4 or 5 marks. There were some students who stated the rule for removing outliers as 1.5 times the interquartile range away from the lower and upper quartile, instead of using the mean plus or minus 3 standard deviations. Students should have realised by the number of marks that a single comment here is not sufficient. This first response was awarded full marks. They have stated that they need to clean the data as they are outliers and given a reason that it would skew the results. They have also given the correct calculation to identify upper outliers and stated that 5.3 and 5.7 are outliers. The next response was only awarded 2 marks. The first mark was given for stating that they needed to clean the data to determine outliers, and the final mark for stating that he needs to remove 5.3 and 5.7. Note that the final mark in this question is for recognising 5.3 and 5.7 as outliers and is independent of all the other marks in this question, so can be awarded without calculations. In this final question, we are going to look at what an extended response question looks like. Extended response questions are less structured than other questions on the paper and require students to select and interpret the appropriate techniques. The overall performance across both papers and both tiers on the extended response questions was mixed. Some students were clearly able to select the required technique, while others did not know where to begin. Students must ensure they pay attention to the number of marks available and make sure their responses fully answer the demand of the question. This was question 5 on paper 2 higher. This is a good example to show that extended response questions don't necessarily involve just writing and can also involve calculations. All papers and tiers will now have extended response questions, and as mentioned earlier, these were the types of questions that students struggled with, particularly the foundation students. In this question, they are given some raw data for Ethiopia and some summary statistics for Pakistan, and are asked to compare the amount of UK aid given to the 2 countries. This question was well received by students, with over half of them earning at least 3 marks here. To gain the first mark, they needed to give a correct mean of 297. The next 2 marks are given for a correct calculation and answer for the standard deviation of 44.3. The next mark is for a correct comparison of their mean or standard deviation, and the final mark is a correct interpretation of both the mean and the standard deviation. The calculation of the mean and the standard deviation were generally accurately completed, though some struggled to use the standard deviation formula correctly. Many went on to compare the means and standard deviations, though few give a contextual interpretation of these comparisons. Numerous arithmetic errors were seen, so students are advised to check over their working carefully. This first response was awarded full marks. They have calculated the correct mean and standard deviation, gaining them the first 3 marks, and have given correct comparisons of both the means and standard deviations. Only 1 comparison was needed for the 4th mark. This final response that we will see today was awarded only 2 marks. We can see that they have a correct value for the mean and were awarded the first mark. They then go on to compare the mean for the 2 countries and have been awarded the second B mark. They have made no attempt to calculate the standard deviation, so can't be awarded any more marks. This is a good example to remind students that when comparing data sets, that they need to compare an average and a measure of spread. I would like to take a moment now to discuss some of the support and resources that Pearson Edexcel offer for this qualification. In addition to this video, there are other student responses with examiner feedback from the Summer 2019 exam in the online exemplars document. For assessment practice, there are 2 sets of practice papers and extra statistical inquiry cycle AO3 practice questions, as well as the sample assessment materials. Exam Wizard includes the new and legacy questions mapped to the 9:1 specification. There is plenty of support for those who are new to teaching the specification, including more training events in the summer term. If you are not already signed up to the Maths Emporium, the details of how to do this are given here. The Emporium is a great source of maths and statistics resources, and the regular emails will keep you up to date. There are also published resources available as shown here. Pearson Edexcel's paid for and endorsed resources are not required for the delivery of this specification. Paid for resources may also be available from other publishers. And finally, for more student responses and examiner feedback, download the exam list from the Pearson Edexcel website. Thank you for watching. I hope you found it useful.